All right, now we're back. We're on the intermediate ball, and we're going to do the rest of the experiments here. We've done one under this set of conditions on this height, which is 30 centimeters minus 5. That height difference is 25 centimeters, and the distance being 43 and a half. And so what we're going to do is we're going to repeat the experiment 2 more times because we've already only done it once. So here's the 2, and it's also 42 seconds, as you can see, or 0.42 seconds. And that's 0.41, but I don't know what that last digit is because it's not real. So let's do it again. It's 0.42 seconds. So let's write those down. 1.5 centimeters, 1.5 centimeters, 30, 35, 5, 25. Okay, and we got 0.42 each time. Okay, now I'd like to change the initial height and move it down to here. We'll redo the experiment, but we have to remeasure the height. The initial height is going to be, in this case, about 15 centimeters. Our sensor height can change just slightly. Oh, I'm sorry. I measured it wrong. Our initial height is going to be, right at 15 centimeters. And our final height is right at 5 centimeters. So it's going to be 15 centimeters. We're still using the 1.5 ball. And we're going to do the height. The clock stop is 5, so it's dropping only 10 centimeters. So we're going to make 3 measurements at that height. Okay, so the ball is attached to the bolt, and now it falls, and it's 0.26 seconds. 0.26. 0.26. So it happened 3 times. The reason you do it 3 times is because there's a certain amount of variation in experiments. And it has to do with factors that are outside your control. Okay. So this is, the ball is now falling. You can see on the ramp that when you attach the ball, the distance it moves until the timer shuts off is 10, 11, 12, 13, 14, 15, 16, 17 centimeters. So it falls 17 centimeters in 0.25 seconds. Okay, so that's 17.0. Okay. Now we're going to change it again. So we're still using the 1.5 centimeter ball. We're going to change it again. We're going to move this back up to the top. Okay, it works. Okay, so we move it back up to the top, and we're going to change the slope. And what we're going to do is make it a little less slopey. Now, I don't know exactly whether this ball is going to roll off to the side. It has in the past, but let's give it a shot at this slope. Okay, release the ball, and it goes down pretty well. And so this now, we'll have to remeasure this height. The height of the ball initially is, I don't know, can you see that? It's about 20 centimeters. The sensor height is about 5 still, so it's 20 and 5, so the difference is 15 centimeters. And what we're going to do is we're going to measure 3 times, and that will okay, so it's 0.56. That's what we got last time. We got 0.56 again. And we're back at 43.5 centimeters total distance. The distance along the ramp is 43.5. All right, now I'd like to do Galileo's experiment, which is to try the 3 different steel balls. We've done the medium-sized steel ball, but we haven't done the big one, we haven't done the small one. So let's see if Galileo, if we're doing this thing the same way Galileo did it. This is the big ball, and it has a diameter of 2 centimeters. And we'll calculate the mass later. So let's let the big ball drop and see how much time it takes. 56.56. Okay, so it drops at the same rate as the medium ball. 0.56. 0.56. So our 3 times, we're getting the same answer we got with the medium ball. So that's 2 centimeters, 2, and it's 20 centimeters height, and it's 5 centimeters sensor height, 15 centimeter height difference when the ball drops. It's 42.5, and it's 0.56. So, from that you can conclude that the medium ball and the big ball drop at the same rate, which is the same as what Galileo concluded. Let's try the small ball. We might be surprised by the small ball for the same reason that if you drop a feather, you don't get the feather falling at the same rate as the ball, because the feather has less air resistance, a lot more air resistance relative to its gravitational force. So we always use an excuse when we drop feathers. So let's drop this little feather and see if it drops as fast. So we're going to drop it from the other magnet. I'll tell you why later. And it has 0.58 seconds, so it's a little bit more. And that's a bad reading. 0.57. Okay. Uh-oh, 0.77, but you saw it stick at the top, right? So it's not quite fair because the ball's sticking more than the heavier balls do before it starts. Yeah, see, it's just sticking now all together. So the ball is starting to magnetize. So the magnetization is affecting its reading, and I'm not sure we can even drop it anymore. Yeah, see, it's stuck. So we got a 0.58 and a 0.57, but we weren't really able to continue the experiment because the ball magnetized and stuck to the screw. Okay, so this was the 1 centimeter ball, and it's dropping 20 centimeters and 5 at the bottom, so it's 15 for the difference from 43.5. Okay, now let's do a couple more experiments, and let's take this initial point down to where we had it before. Way down here, and drop the ball from 17 centimeters, and we'll do the medium ball. Well, let's do all three of them. Let's do the small ball. Well, you can't do the small ball because it's magnetized. But we can do the medium ball and the big ball. Okay, this is from 17 centimeters distance, and it's 0.35 seconds. So this is the medium ball, so it's 1.5 centimeters in diameter. We have to measure the height it dropped through. And we'll do it this way. It dropped 20 centimeters, excuse me. It dropped 12 centimeters, and the sensor is at about 5. So it's 12 centimeters initial height and 5 final for 7 total drop, and it took 0.35 seconds. And the initial position was 17, or the height along the ramp. It dropped 17 centimeters, so that will determine what its velocity is. All right, so that's one drop. Let's do 2 more, because we're doing 3 per. 0.36 also. 0.36. Okay, so let's write that down. And all right, now let's do the big ball. Do that? Yeah, let's do the big ball. Point 0.36, 0.36, 0.36. Okay. So the 2 centimeter ball, the initial height being 12, final height being 5, the ball drops 7. It's a 17 centimeter fall along the plane, and it also got 0.36, 0.36, 0.36 seconds. So its velocity is going to be largely the same as the medium ball, which also got 0.36 seconds. Now, let's go on and let's try one final thing, and that is we're going to raise the ramp to drop it as close to vertical as we can. And looks like we're going to have to mess around with this thing a little bit. I think I'm going to turn off the recording of this until I get the circuit fixed, and we'll